If you haven't had enough of the Minions memes shared by millions of moms on Facebook, you are in for a good time today. We will be explaining the physics behind totally realistic scenes in Despicable Me, all while having a blast and maybe seeing a meme or two ourselves.
As is the case with all cartoons, these scenes follow the laws of physics perfectly, and everybody should be alive and well by the end of this particular clip. Think of it as these are so safe and realistic that if you placed your newborn child in place of these characters, they would come out perfectly fine.
So now that that is said, let's get into the silly goofy scene in Despicable Me when Gru decides to play God and shrink the moon. On a quest to find the One Piece, Gru gets mixed up with the wrong crowd, the minions obviously, who manipulate him into following their master plan. On his quest, he encounters his greatest rival, the embodiment of math with both direction and magnitude, Vector himself.
Let's begin by taking a look at Vector's liftoff. If you take a look here, we will show you the clip in question.
Nice work, Doctor. All systems go.
Now that we've seen this clip, let's ask ourselves the important question. Would Vector survive this? The only way to really find out is by human experimentation. However, that isn't entirely legal. So let's move on to the next best thing. Probably physics.
In order for us to go through with the calculations, we first must have the speed of the rocket, the time for Vector to accelerate to the speed of the rocket, and Vector's mass. We found out the speed of the rocket by analyzing NASA's rocket launch data to find a comparable speed of an actual rocket at the same height as Gru's rocket as Vector is snatched up.
Then we analyze the number of frames it took for Vector to go from the ground to the speed of the rocket for the time. Each frame is a 30th of a second, and it takes Vector 5 frames to accelerate, making the time of his acceleration a sixth of a second. In addition, according to Google, Vector is approximately 3 foot 7, so it is reasonable to assume he weighs about 30 kilograms.
Now that we have gathered up our givens, we can calculate his acceleration. Acceleration is equal to the change in velocity over time, and Vector starts from rest and accelerates to 2,500 meters per second in 0.167 seconds, making his acceleration 14,970 meters per second squared. With acceleration, we can calculate the force exerted on Vector's spine as he is pulled up from the rocket.
As a wise Newton once said, F is equal to ma. As we previously defined, Vector has a mass of 30 kilograms, multiplied by his acceleration of 14,970 meters per second squared, meaning the force he experiences is 449,100 newtons. The average force it takes to snap a human spine is 3,000 newtons. So assuming the rope is indestructible, that's enough force to snap Vector's spine almost 150 times. Bro is dead.
Now that we've seen that Vector snaps, or the rope snaps, let's move on. Once Gru makes it into space, some funky things happen. Let's watch this clip to see.
I've got.
Okay, so there are so many things wrong with this scene, starting with the fact that Gru basically creates and holds a miniature black hole in his hand. When Gru shrinks the moon, because of the law of conservation of mass, the moon's mass should stay the same, and the moon just becomes more dense.
The force of gravity between two objects is given by the equation F is equal to gmm over r squared, where g is the gravitational constant, the m's are the masses of the two objects, and r is the distance between the objects' centers of mass. The net force acting on Gru is equal to the force of gravity from the moon, so we can set ma equal to gmm over r squared.
Gru's mass cancels, so his acceleration is equal to the mass of the moon over the radius squared. The mass of the moon is approximately 7.3 times 10 to the 22nd kilograms, and the distance of their center of masses is about 0.45 meters, which is an estimation comparing the moon to Gru from what we can see in the video. Which means Gru experiences an acceleration of 2.4044 times 10 to the 13th meters per second squared, which is massive. Gru would be wrapped around the moon like a piece of spaghetti is wrapped around a meatball, or in more modern terms, Gru would get boxed like a fish, as the kids would say.
As seen previously, the tides got and disappeared. However, this raises some questions from the Council. Unless physics lied to me, mass cannot be created nor destroyed. So by shrinking the moon, it has the same mass and remains in the same place it was before. So up close the gravity would be funny, but from far away, like the pull of the tides, there would be no change. So the tides should have remained their same old selves.
So what conclusions does this lead us to? Well, unless the rope is weak, like my jokes are, Vector would be brutally snapped in half in comparison to stepping on a twig. Which, we've all stepped on a twig and seen how it can snap under the pressure of your foot, but imagine Vector spine under the pressure of the rope. Gru would then be accelerated with a great amount of force into the moon, and it is unknown exactly what would happen to him, but it certainly would lead to his death. It was hypothesized by us that the moon would just decide to go inside of him and create a hole through him, but this isn't proof for sure. The last thing I would like to discuss is that the tides seem to be a little silly goofy in their actions and should have remained the same as before and not disappeared like seen in the scene. Before I close up the video, I would like to say that if it were not a kids movie, this scene would certainly lead to the brutal end for our beloved characters. Thank you for watching.